Okay, welcome everyone. So thank you very much for joining. We've got a wonderful talk today given by Julia Barfield and Jane Wernick on a masterclass in the intersection between architecture and engineering. So I'll just give you a biography on Julia, followed by a bio on Jane. So Julia is Managing Director and Design Director at Marks Barfield Architects. Julia co-founded Marks Barfield Architects in 1989 with David Marks, 1952 to 2017. Is joint originator and creative entrepreneur between the London Eye and the Brighton i360. Was awarded an MBE in 2000 and shortlisted for Women Architect of the Year 2017. Qualified at the Architectural Association after spending a year out in South America working in the barriadas of Lima, Peru. She helped establish Architects Declare in 2019 in response to the climate emergency, which has 1,400 UK signatory practices and has now spread to 28 countries globally and over 6,000 signatory companies globally. Her diverse portfolio of work across many sectors, from education, culture, residential and workplace, to bridges, sports and leisure. MBA has won over 130 awards for design, innovation and sustainability, including being shortlisted for the RIBA Sterling Prize twice. The practice has focused recently on the circular economy and projects that stay within planetary limits. Projects include The Lantern, 75 Hampstead Road, London, a workplace exemplar of well-being principles, biophilic design and sustainability, and the UK's first green mosque in Cambridge. MBA is currently promoting the West Somerset Lagoon, a tidal range project, potentially one of the largest renewable energy projects in the UK. She is a past chair of the RIBA Sterling Prize National and International Awards panel and sat on the LLDC Quality Review panel and is an external examiner at the UCL London for the combined architecture and engineering course. She has lectured in various schools, universities and conferences in the UK and overseas. Moving on to Jane Wernick. Jane is a structural engineer who is particularly interested in working on projects that give delight and is engaged in our response to the climate emergency. She is specialised in the design of structures which play a large role in the total architecture of the building. In addition to the more usual structural forms and materials, she has a wide experience of working on projects with irregular and complex geometries and of lightweight structures, and has worked in both Europe and the USA, and on projects around the world. She worked for Over Arup & Partners from 1976 to 1979 and from 1982 to 1988, and for Bird Air Structures Incorporated from 1980 to 1981. She was principal in charge of Over Arup & Partners Los Angeles office from 1986 to 88, and was an associate director of Over Arup & Partners from 1989, where her most notable project was the Millennium Wheel. She founded Jane Wernick Associates Limited in 1998, whose projects include the Young Vic Theatre, the Kew Treetop Walkway, and the Living Architecture Houses. In 2015, the practice was incorporated into Engineers HRW, to whom she is now a consultant. She has taught at numerous schools, including Harvard's Graduate School of Design, the Architectural and at, I'm missing out something there, and at Southampton University. Architectural Association? Architectural Association. She has served on many design review panels and was a member of the RIBA Building Futures Steering Committee, 2005 to 14, for whom she edited the book Building Happiness, Architecture to Make You Smile. She has been an active member of the multidisciplinary built environment think tank, The Edge, since 2009. She won the 2013 First Woman of the Built Environment Award and was awarded a CBE for services to structural and civil engineering in 2015. So thank you very much, and we look forward to this wonderful conversation.
Thank you.
Okay, well, thank you for that. I think we can go home now. How many engineers do we have and how many architects? Okay, engineer and architect. Okay, so how many engineers, first of all? Okay, and how many architects? Okay, yeah, good, very good. I mean, it might be a bit more friendly if you came a bit further. I think there's a room down here, but anyway, up to you. When I was asked to do this masterclass, intersection between architecture and engineering, it just seemed to me the best way to do it was actually to have a conversation between an architect and an engineer. And Jane and I have been working together for most of our professional lives. So, you know, we hope that it'll make more engaging conversation and making a more engaging talk. Okay, so
It's not moving.
it's not moving. That's a good start. There we go.
Should be again.
Okay, very good. Okay, so as you've just heard, I founded Marks Barfield with my partner David Marks more than 35 years ago, and we have a very diverse portfolio, including some projects where we became entrepreneurs as well as architects. And we've been told that our work is very difficult to categorise, and we don't have a house style. Each project is very different, coming as it does from a thorough understanding of the site, the client's needs, the aspirations, its history, broader social and environmental imperatives. And all our projects are site-specific. So to us, it would be strange if each project was not different. These are some of the more engineering projects. We work with, not just Jane, but with many engineers from many different companies. So this is more of our kind of bridge projects that we've worked with many different engineers. We operate from a studio in Clapham, South London. We've had a 50-50 gender balance from the beginning, and that wasn't difficult because it was me and David. And we've always integrated sustainability into all of our projects from the very start, and had a very kind of social bent. And our ethos is that where we like to work in close collaboration with engineers from the very beginning, and that's structural and M&E. Because to us, the design has to emerge from the way a building works, not simply the way it looks.
So, as you heard, I started my career at Arups and then set up my own practice in '98, and then we were incorporated into Engineers HRW in 2015. But I've been lucky in my career to have worked with many interesting and good architects. I characterise that as architects who care about what they're doing, and also increasingly now become, as Julia has, we've become more focused on our impact on the built and natural environment. We'll talk about some of these projects, but we won't be talking about any of the ones that I did a lot of work with Zaha from the early days, and worked on the Cardiff Opera House competition and that scheme. I've done quite a lot of work with David Chipperfield and the Jane Wernick Associates. We did a lot of projects with them, and we were very lucky to do the Living Architecture projects, which are all with architects who care, ranging from Hopkins to Peter Zumthor to smaller practices like Nord. So that's been really enjoyable.
But I'd just like to start with an outstanding example of the beautiful fusion of architecture, engineering and innovation, the Palm House, that was built in 1844. David Marks and I were asked to say what our favourite building was, and we actually decided that this was it. And really, it was a collaboration between Decimus Burton and the engineer Richard Turner from the Dublin-based iron foundry factory. So he was not just an engineer; he was a contractor, and innovator and risk taker. And the lightness of the structure is extraordinary. It was Turner's idea to create the structure entirely out of iron, with the ribs out of wrought iron, enabling them to be a fraction of the size that they would have been in cast iron. And it also uses an innovative tension system with an iron rod that locks the ribs together. And in 1988, which was the last time the Palm House was renovated, there was a month where you could go into the Palm House and take pictures without any plants. And so these are pictures from then. And you can see how it's just an extraordinary example of building lightweight structure.
So I was quite fortunate about a year after I graduated to be moved to a group that was working on this project called COCOMAS, which was to be the government buildings for Saudi Arabia. And Fry Otto was the architect for the special structures. And this was at the time just after Ted Happold had left Arup to found Bureau Happold. And he took a third of the project and 2/3 remained with Arup. And Fry Otto said he wouldn't carry on working with Arup unless Peter Rice would be involved, because Peter had actually left Arup after Centre Pompidou to set up a practice with Renzo Piano called Piano and Rice. So I was sort of the baby of the group, doing analysis on these structures. That basically it's the hanging chain net model you can see top left. So everything is in pure tension under its own weight, and you freeze it, turn it upside down, and theoretically everything goes into pure compression. Of course, that isn't strictly true because you get axial shortening, so the geometry changes and you get a lot of secondary bending. And for the flatter structures, you get a massive amount of secondary bending. Also, these were tubular structures to be built in the desert, clad totally in glass, and then with parasols on the outside to provide shading. So in a way, it's probably a good thing that it didn't get built. But for me, it was very fortunate because I met Peter Rice at that stage. And I think he always liked unusual people. And frankly, just by dint of being female, I qualified. And so he did become a mentor from that time on. And well, it was a few years later, but he set up RFR, which is Rice, Francis and Ritchie, so an engineer and 2 architects. They did this competition for Parc de la Villette, which had been built as an abattoir in Paris for everyone to bring their livestock from all around the country, which was pretty stupid. And there was a lot of corruption involved. So later they decided to turn the building into the Museum of Science and Industry. These glass facades are the precursor of the Pilkington planar glazing system. I particularly like the structure, again, a bit like the Palm House. It looks very light. It isn't necessarily very light, but it looks light. And the horizontal tubes carry the weight of the pieces of glass to the vertical tubes, the columns, and all the wind loads and horizontal forces are taken by cable trusses behind the glass. So these diagrams, on the right, you've got the big cable truss which stabilizes the columns and beams, and then behind each kind of seam between the pieces of glass, you've got those little cable trusses. So when the wind blows into the building, it's the inner cable that takes the tension, and when it comes out, it's the other cable. And it's actually quite a flexible structure. And so we had to really worry about how you would attach the glass. And glass is very strong in tension and compression, but not very strong in bending. Well, it's the tension part that it's not so good in because it fails brittly. So we had to make sure that we didn't put bending stresses into the glass as it deflected. And so you can sort of see in that exploded mechanical bit, there's actually a spherical bearing that goes round the bolt. So it's as close as we could get to putting a pure pin in the plane of the glass, which is something that stuck with me.
Okay, but then we actually did meet because of...
Oh, yes, I forgot to say that. Yeah, on COCOMAS, when Peter got involved, he decided that he would organise an exhibition of lightweight structures. And this is when I first met David and Julia.
Yes, because when we left the AA, we actually set up a model-making company. We didn't actually go and work for architects straight away. And we were doing all the models of the lightweight structures because it was a seminar where they invited engineers to come from all over the world and learn about lightweight structures with Peter Rice and Fry Otto. And we were lucky enough to hear Fry Otto give his talk, which was absolutely amazing.
Yeah.
He had the wisdom of an old man and the enthusiasm of a child. It was just fantastic. And then after David and I set up, we decided to go in for this competition, the Bridge for the Future, which was organised by the
Institution of Civil Engineers.
Institution of Civil Engineers, and they called for a bridge of the future that had some relation to nature. And that got us thinking about what was nature's biggest bridge, and we decided that it was the spine of a dinosaur. So that generated the idea for the bridge. It should be a series of vertebrae.
In fact, Darcy Thompson talked about this.
Yes.
Where your bones take the compression, it's a quadrupedal bridge. The bones of the animal take the compression, and the tendons govern the deflections. So I said, well, since we were either side of the Grand Canyon at the time, because that's when I was in LA running the office. So I said, let's go over the Grand Canyon, and it's actually fixed on the left-hand side, so it's supported vertically and horizontally, but on the right-hand side, it can actually slide to the right, so it's only supported vertically and transversely. And so that's why it's only for pedestrians, not cars, because it might be a bit too wobbly for cars. But anyway, it was
and importantly,
good fun.
we won the competition.
We won the competition.
Yes, we actually won. Yeah. So this is one of the drawings that you did from, because we were communicating by fax machine.
Yeah, there were no emails in those days.
No emails, it was all by fax.
And even faxes took a long time.
Yes.
So this was the sort of thing that the way we would communicate.
Yeah. And then, so moving on to the story of the London Eye. So the story starts in 1993 when there was a competition organised by the Sunday Times and the Architecture Foundation calling on ideas of how we were going to celebrate the millennium. And David and I had set up in practice a few years earlier. And after fantastic experience, we worked for both Rogers and Foster's. We won a competition for a £30 million project. And the client insisted that we move out of the shed next to our house and get a proper office. So we actually bought an office. But then the £30 million project evaporated in the recession of the early 90s, and we were left with overheads 10 times what they had been. So we needed something to cheer us up. So we decided, and we had some time on our hands, so we decided that to enter this competition with a 500-foot wheel on the South Bank. Now, as you do. So why did we choose that site? Well, if you draw a circle around London, you'll find that its centre is there on the South Bank. And as the wheel was designed to enable Londoners and visitors to London to see London from a new perspective, where better to do it from than the very centre, from its very heart. And there were many initiatives at the time also to regenerate the South Bank, because at that time, you just went to a concert at the South Bank Centre and then went home. There was a statistic that we found where that about 1.5 million people used to go halfway across Westminster Bridge, take a photo of the Houses of Parliament, and then go back north. So this project was all about pulling people to the south and regenerating the South Bank. And also, Jubilee Gardens was the site of the Festival of Britain in 1951. So there'd been a great celebratory heritage on this site. So there was many reasons to choose this as the correct site. And of course, we asked Jane to work with us, she was at Arup at the time, and we attempted to redesign the wheel, which is probably...
So I got this phone call just before Christmas. Would I come for a meeting? Yeah. And Dave and Julia said that, they wanted a wheel of the 21st century, so to be as transparent as possible. I think ideally they would have had nothing between the spindle and the rim, and I explained that would be tricky. So the least structure we could have was this beam going right the way across. But of course, it did have two huge semicircles of complete daylight, but does mean that the rim is quite heavy. But we also, Julia had spotted this site right next to County Hall, but the other crucial thing is that it's actually hanging over the river, and so that meant we needed a cantilever spindle. And the other thing was we decided right at the very beginning that the capsule should be on the outside, not dangling inside a truss, and that was that. So this was a first.
So it was very much the idea that the visitors would be like on top of a mountain in the middle of the city. They would have a 360-degree view, and that was what we were trying to create. And
it wasn't a white knuckle ride.
No, it was very gentle. But we didn't win the competition. In fact, nobody won the competition. But we thought it was a good idea, so we pursued it. We founded the Millennium Wheel Company. We did a back-of-the-envelope business plan, and after preliminary discussions with landowners, we submitted a planning application. And this came to the attention of Mira Bar-Hillel, a journalist on the Evening Standard, and she showed it to her editor, Stuart Stephen, who immediately loved the idea and ran a Back the Wheel campaign. And we also had some very good printable images, because computer imaging had also come of age at that time. And we met Alan Davidson, who was a pioneer in CGI imagery, and the photographer Nick Wood. And we created some great images that got shown in other newspapers as well. And as a result of this additional publicity, the wheel came to the attention of Bob Ayling, CEO of British Airways. And in December 1994, he was looking for a Millennium Project, and we were looking for investors. And he shared the vision of the project. So as a result, he took 50% of the company and loaned us £600,000. And with that, it enabled us to employ Arup properly and do a proper planning application. And also have another look at the structure, because redesigning the wheel was probably not fun.
Yes, so this wasn't the lightest, because obviously you had to span, at the time, 500 feet, that arch. And so we said, well, let's think about the bicycle wheel. So the bicycle wheel is the most magical tensegrity structure, really, because the vertical load comes to it from the spindle, and it's actually the horizontal spokes that are only a couple of millimeters in diameter that stop the wheel going into a horizontal oval. So they go into tension, and obviously the support is provided from the ground. Also, there's a very slight angle between the spokes that go to either end of the hub, and that just takes some of those lateral forces. So our wheel is quite different in that it's supported not from the ground but from the spindle, and all the weight is coming from all the capsules around the rim. And so that tends to make it go into more of a vertical oval, and it's the vertical cables then that is keeping it circular. Also, we've got the cables going to either ends of the spindle to resist the wind loads. And in fact, for this wheel, it's the horizontal loads are pretty significant, of course. So when the wind blows, the cables that are on the windward side get more tension, but the ones that are on the leeward side tend to go slack. And obviously we don't want any of the cables to go slack, so we pre-stress it. And so that puts the whole thing into compression, and I'll come back to the consequences of that a bit later. And then, but also right away, we had the capsules on the outside. And so this was the structure that we developed for the planning application.
Yes, yes. So over the next 2 years, David and I presented the project to all the principal authorities, the government bodies, English Heritage, Royal Fine Arts. Well, that didn't go terribly well, but anyway, most of the other societies were really positive about the project. And then then we got consent, full unanimous consent, in October 1996, and in 1 month later. So this is a model that we were able to build with the £700,000 that we got from British Airways, and this is one of the other images that we presented. This is the Queen's eye view from Buckingham Palace, and you can see that it's still it's 60 capsules. So we still had 60 capsules at this stage, because we saw it as a symbol of time passing. So 60 minutes, 60. And then 1 month later, the then Secretary of State for the Environment gave his opinion, and he could have called it in. So it was John Gummer at the time, and if he called it in, he would have killed the project. But instead, he wrote a parliamentary answer that said, "The wheel is an inspired idea that has caught the people's imagination and will boost the economy of the South Bank."
And I was lucky. I was on holiday in Singapore.
Yes.
So I received this fax, and you can imagine me leaping around my bedroom in that hotel at this brilliant news.
Yes, yes. So that was so we had full speed ahead, so then we were able also to develop the idea. Although one of the things that came up was the British Airways wanted to have a turnkey contractor, so that was a bit complicated, and also we didn't have the main funding, because we decided right at the beginning not to go for public money. We wanted to. So David then bought a suit in order to go and talk to all the bankers. But our saving grace was about that time we had found the specialist subcontractors. And this is a theme that runs through many of our projects. On the structural side, we'd found Hollandia, and they had built the flood barrier across the Rhine. And each of these pieces is a moving piece that's the length of the Eiffel Tower. So we felt confident that they were able to do a large moving structure. And we also had brought on board Poma, who had obviously had built ski lifts in the past, moving capsules, we'd involved them in early stages to help us design the capsules, and Hollandia to help us design the structure, but also the construction sequence.
Yeah. So one of the things we wanted to do was also to make the wheels sit as lightly as possible. So this was the original concept for the support structure. It's basically an A-frame, and the cables at the back stop the whole thing from falling forward into the river, and the weight of the wheel is such that however strong the wind is blowing, it would never tend to blow the other way. So we didn't need cables going down into the river as well, which was lucky. And we had that kind of little A-frame at the back to deflect the back cables so that they would be coming down to the ground vertically. So that was minimizing the horizontal forces. Later that got changed because the construction method changed. So at the time, Arup's project manager group, Peter Platt-Higgins, was looking at how we would construct it. And the original plan was that we would have built it actually in segments, but vertically, and then attach the capsules at low level. But later that changed. And so the final design, as you can see, doesn't have that back A-frame, but it does mean that you have to have those big ground beams connecting the piles under the 3 support points.
And you also, you also see that here we've actually changed the number of capsules, so it's no longer 60 capsules but 32 capsules, which is what we've got now. And that was actually quite a good thing, because to keep it within, to be affordable, but also you're not seeing the person in the capsule next door. You actually do see that 360 degree.
So
that was a cost. Value engineering was beneficial.
Yes, and actually you can see that there's a structure to the right that's in the river. When you go, you'll see that there's another pier, and it works as a pier, but it's also providing vessel protection. So we had to design the wheel, even though most of the time the water is very, very shallow under the wheel. We had to design for a 60-ton vessel hitting the wheel, so that's protection for that.
Yeah.
I mentioned about we had to put a lot of pre-stress in the cables to make sure they never went slack. But of course that then put compression into the rim, and you all have seen a buckled bicycle wheel, where 2 quarters come towards you and 2 away from you. And that's what we really had to do a lot of analysis to try to work out the optimum size for the triangular perimeter truss and the optimum length of the spindle, because the longer the spindle was, the larger the angle between those wind-resisting cables, which meant that the forces were less. But on the other hand, you didn't want the spindle to be too long, because then it was just impossible to build. And similarly, if you made the truss a lot stiffer by making it bigger, you would make it heavier, and then you'd need more pre-stress to counteract those forces, so you'd be going around in circles. So Pat Dallard, I don't know if some of you remember him, a structural engineer, but he wrote fantastic programs so that we could optimize those dimensions. And then we worked hard on the hub and spindle and what it should be made of, and obviously it is a bit like a bicycle, and we've got two sets of ball bearings, which you'll see what it ended up with finally, but it was not so different from this. And again, we looked at lots of different combinations of how many spokes would be the best and the most efficient, so that we weren't getting buckling, that we could make the rim as light as possible, and also we were always aware that we had to make sure that it would still be beautiful. it's in this major position that I would say that a large part of the architectural community were quite snippy about the project anyway.
They were quite snippy.
And so we were all the time conscious of trying to make sure that it was beautiful, but also structurally efficient. And David was always going on about structural efficiency.
Yes, but also to be light in feeling.
Yes.
So these, there was more than 100 options, you can imagine. Now, just focusing on the capsule design, the fact that the capsules are on the outside means that they're supported with circular mounting rings attached to the ring, and they have to be motorized. There has to be a motorized stability system that drives the capsules around and maintains the level.
We worried about a whole team of rugby players jumping on one side so that by the time it came round, the wheel would be upside down. The capsule would be upside down.
So, but the fact is that the capsules are aerodynamically shaped to minimise the drag on the main structure. Now, wait a minute. So on this one, this was a very early design, and the outboard mounting ring is on the outside, and then we found that having it on the outside actually contributed to about 40% extra of the total wind resistance. So we pulled the mounting rings onto the inside, and that dealt with that issue. But it's quite a complex system of maintaining the level, and you can see it's all under the floor. I'm not sure if we've got time to go into it in too much detail.
No, but there are wheels under the floor that run on the inside of like a huge cogwheel, and they're motorised, and that's all linked in.
Yeah.
And it was a very good combination of Nick Bailey, who was working on the appearance and how it would function for the number of people using it, and John Lyle in Arabs, whose background is more car design, and then Poma as well feeding in.
Yeah.
So it's a really good collaboration.
And the thing about it is that although it ends up being quite innovative, all of the pieces that are used there are actually pieces that existed. The technology existed. So it was the innovation part was actually bringing tried and tested technology together in a new way, and that was the kind of the innovation of the thing. And then so I mentioned before that British Airways wanted to have a main contractor wanted to have a main contractor, and we actually went out to tender, and then Mitsubishi were signed up because they were £10 million cheaper than anybody else on Christmas Eve 1997. But during subsequent negotiations, they reduced the size of the wheel, and they reduced the numbers of capsules, which was actually a good thing. But by April 98, things had gone very much awry, and there was a fateful night when we were forced to kill the project. Mitsubishi were insisting that the only way that they could achieve the programme and our immovable deadline was to do bog standard capsules, and this was what they showed us. This is what they wanted us to do, and this is literally the specification. English oak floor, another cheaper material, handrails replaced with iron and steel. Remove the stability system and replace with a gravity system. So we were presented with this, and we were actually told by our partners that if we didn't say yes to this, we would kill the project. So we had no option but to kill the project, because we would have been laughingstocks, and it's not what we got planning permission for. So we did say no, and then it was actually Tim Rennick, who was a project manager at Mace, who helped patch things up. And at a crucial meeting of British Airways, they agreed to change the funding structure that enabled the construction of the wheel to go out in individual packages, and Mace were appointed as construction manager. So Hollandia and Poma were the principal subcontractors, and then in the end we found no British money. It was a German bank, West LB, and a Japanese bank, Sumitomo, who actually funded the wheel in the end. But by that time, what should have been a 2-year programme had to be built in 15 months. And this is the site in December 1998, with 1 year to go, the tops of some 44 concrete piles that go 33 metres down into the ground. And then this is the Hollandia factory, and over 60 welders worked in 3 shifts for 8 weeks to manufacture the rim. And it was in a 64-sided rim that was constructed on the jigs in Hollandia's factory. And then this is the each of the 16ths completed. The rim section are welded together as quarter sections, ready to go across the water to come to London.
Yeah, that was fortunate that pieces could come just by sea the whole way.
Yes, they just came on barges. And meanwhile, in the Czech Republic, the spindle is being made, and it was fabricated in 7 sections of cast steel using a very special steel recipe that each piece took 2 minutes to pour and 1 month to cool down. And a crucial piece of engineering, of course, is the spindle, because it takes all of the weight, as Jane has described. And then this back in Holland is the hub being fitted to the bearings a bit later on with all of the bearings, in German bearings. And this is the hub and spindle being put together. And then this is the cables being spun in Italy. Italian cables that were actually quite innovative in their own right as well.
But you know, when wind blows past a circular section, there's always a tendency, if it's constant, but you get a slight horizontal perturbation, and you're seeing chimneys with a strake going round, which stops the airflow being so constant. These smaller elements give the equivalent of that, but it's like a recessed strake that goes very, very slowly around, or gently around the cable. So that was a good innovation.
And then this is the glass being made. So this is just outside Venice. So we have Venetian glass. I mean, ideally we would have had the molds would have been ceramic molds, but we didn't have either the time or the money for that. So we discovered a company outside Venice that could do them in steel molds. And basically we did this steel mold with a sacrificial layer of glass that was then taken away and recycled. And this is one, the glass coming, because it was actually, we think, the most double curved glass, the biggest double curved glass that had ever been done at that time. And this is the capsule frames being assembled in the factory in Grenoble. And this is the first quarter section coming through the Tower Bridge. We found out afterwards they didn't actually need to raise it, but they did anyway, just because of a bit of theatre. And actually, the fact that it was so visible on the river was quite an interesting, I think, created quite a lot of buzz around. And you can see that it was going to be built vertically, but then Hollandia in October '98 told us that they had real concerns about safety and programme.
And I was quite lucky that because of the bend in the river, it's actually much shallower on this side, and it means the navigation channel is on the other side. So this wasn't in the middle of the navigation channel.
Yeah. And so it was built vertically, and there was, and then this is that when it was completed, and it was just about ready to be lifted, and this is it being lifted at 32 degrees and at 62 degrees. This is Boadicea welcoming the London Eye onto the skyline, and this is when it was vertical. And then next, of course, came the capsules, looking like huge dinosaur eggs. And it was amazing because by that time we'd lost a bit of time and we had this immovable deadline, and they were able to fit all the capsules in 9 days. And this, of course, is the
Millennium.
Is the Millennium. That was actually a picture from the Millennium. And yeah. And one of the things that I'm most proud of is that when we actually did the wheel originally, we only had permission for 5 years. And after about 4 years, it was clear that it was very popular and very successful. So we then went back to get a further 25 years to Lambeth Council. And David and I insisted that 1% of the ticket revenues from the London Eye should go to the local community in perpetuity. And we recently had an event that celebrated that. And it turns out that in the last 20 years, that's amounted to about £14 million that's gone from the London Eye to local community groups and to the South Bank. So that's
great.
That's pretty good, I think. And then this is another conservatory project that we did together. This was a project for the Regent's Park Conservatory that sadly did not happen, but we were trying to
another glass and tension structure.
Yes, really trying to do a kind of 20th century version of what Decimus Burton and Richard Taylor did. But sadly, it wasn't liked by certain gentlemen of royal distinction. You can,
if the word carbuncle means anything.
Yes. Then moving on to the treetop walkway. This is a project that the tree person wanted to get conceived to give visitors an experience of the forest canopy, and he had already built a mock-up of a treetop walk to see if it would be popular.
And it was very popular.
And it was very popular.
And but it used scaffolding, which is very expensive to keep.
Yeah. So then we were brought on board as the team to do the treetop walkway. And an early decision really was what material it should be built out of.
So Julia and Tony Kirkham, the arboriculturist, and I, we walked round the site, which had been laid out originally by Capability Brown, and in fact there was a cherry picker there so that we could see how high the pylons needed to be, which is 18 metres, and we discussed what kind of structure we should have that wouldn't compete with the trees, but because the purpose was to see the trees and the canopy and appreciate that. And we thought about timber, but it would have been too massive because 18 metres is very high for a column. And so, but if it was steel, if you had to paint it, you'd have to choose a colour that wouldn't kind of stick out like a sore thumb, and also that would be a lot of painting. Yeah, a lot of maintenance.
Yeah.
And so when I said, what about weathering steel, Dave and Julia are already really keen on that material, and Tony Kirkham was very happy with it as the material that would be set against his trees.
Yeah.
And that turned out to be a very fortunate decision.
We'd done an office trip to Naples, and there was this huge Richard Serra sculpture. So it seemed, it's obviously a material that's very beautiful as well as practical.
Exactly. And this is the site of it. Do you want to?
No, I don't think we need to say anything about that.
So what I like about, what was very fortunate about the choice of weathering steel is you can't get rolled sections. So QS couldn't tell me that I had to have circular hollow sections as the pylon, because I think that would have been horrible. I mean, I particularly don't like circular hollow sections actually, because I think they always look bigger than they are. And I'm very fond of triangular sections.
Which looked thinner than they are.
They look thinner than they are, and you get that sharp vertex. And also it meant we could taper it, and that would be more economical to taper it, because it doesn't need to be as big at the top as it is at the bottom. And so that's what this is showing.
And also we decided that we wanted to incorporate the Fibonacci, because
all architects love the Fibonacci
sequence. Yes, of course we do. Mathematical rules of the universe are visible to us in the form of beauty, as John Michel said.
Exactly.
So we decided that we wanted to put all the structure in the handrail. So you've got to have a handrail. So we just didn't want to have any extra structure either above or below. So it's all in the.
And in fact, a very clever thing that Julia Barfield did was that they said, because you've got that 100mm gap and we looked at other options where we had diagonals at 100mm centres, but it was just too fussy. But they said, well, we can use this kind of expomet as the cladding, and that the structure should just be what it needs to be. And then trying to think about how we could incorporate the Fibonacci sequence. So it starts off as small numbers that get wider and wider, and of course with the truss, the shear is greatest at the supports, so that's where you would need the most diagonals. So I said, let's make the spacing of the intersection of the diagonals with the bottom boom. Like the top bit is the balustrade. The middle bit is the floor. And
so it's like the whole thing folded out.
And also we said, let's not have more than 3 diagonals meeting at one point. So then Julia and I sat down and we kind of doodled joining the dots to satisfy that rule. And you can see the bit that shaded pink, that it can be flipped. So it's
a repeated. It's something that could be, for manufacturer, off-site manufacturer, it's a lot of repetition, which obviously makes it more
and yet it
economical.
Looks a little bit,
And the thing about this project is that we also, like the other projects we've talked about, we also involved the maker very, very early on. So,
yes. So it was. Or let's talk about this a little bit more.
Yes.
So obviously we had to have foundations for these very tall pylons, and they're going to have quite a lot of horizontal forces on them. So you had to have a minimum of 4 piles at each location for the wind in any direction. And normally you connect your structure to your piles with a pile cap 1 metre deep thick of concrete. But the roots of a tree, it's like a wine glass. The roots go out horizontally in the top metre of the soil. And if we were to put a big concrete metre thick piece in the ground, we'd have severed all of those roots. And then we did do a mock-up, a plywood mock-up of the pile cap being above ground, and it looked horrible, of course. So we decided instead to join the piles together with this very, very heavy steel grillage. So it's a steel pile cap, which is quite unusual, but it meant, at each location, therefore, the piles had to be specifically placed to avoid the tree roots, which were surveyed. And so they're not perfectly square, and in some cases, in fact, we needed more. And
so this shows the fact that we had that survey done of all the tree roots, and we actually had to move the pylons to be out of the positioning of the main roots of the main roots. Yeah. And then this just shows the
So this is where I'd like to talk about Britland Steel and Tony Marriott, who we actually brought on kind of in what would be now stage 5, I suppose. So that we were happy that he would be able to build what we had designed. But it also turned out he got on really well with Tony Kirkham and the tree surgeon. So they really worked together perfectly, and it was a really happy project from that point of view.
And then this is some of the images showing it. So I think it really does kind of sit comfortably in its surroundings.
Yes.
And then quickly, this is the I360. So as a kind of son of the London Eye, really. I mean, we kept on getting asked by various people to do wheels around the world, and we kind of realised that not many places could afford a wheel as such. And anyway, the experience of rising slowly up to a great height was what was really people were wanting. So we decided to kind of redesign the means of getting up to the great height for a lower cost. And this is the result of that. And I mean, I won't go to it in too much detail because I think we're running out of time. But we basically got the kind of old band together, so Hollandia did the structure, Poma did the capsule, and we built a version of that in Brighton, as well as, and it was a heritage project as well. So you can see the toll booths on either side of the tower. They were one of them was completely destroyed, and the other was virtually derelict. And so part of the project was also rebuilding the toll booths, and we rebuilt them to the same with the same engineering as had been done originally. We also, the project paid for redoing the public realm either side of the I360. So it was a regenerative project as well, because that part of the Brighton seafront was virtually derelict when we started. And this is the kind of experience that it produced, as well as this was actually an amazing evening where we had a moonrise on one side and a sunset on the other side. So Cambridge Mosque. So this is a competition that we won in 2009 and took 10 years to realise. We worked with many different engineers on this project because it went on for so long. It was very much a stop-start project, mainly because of funding, not because we didn't get planning permission. We actually got planning permission quite quickly. This is that photograph really just shows the need. All those bums in the air in the street shows they really did need another mosque. This was the site that had been identified in Cambridge. It was in a residential area just off Mill Road, if you know it. It had been a former warehouse site. And of course, we hadn't done a mosque before, so we did a lot of research to inform us about the sacred Islamic architecture. And what we found out was that mosques throughout the world are actually very different. I mean, you may have the idea it's all to do with a dome and a minaret, but actually, if you look at a mosque in China, if you look at a mosque in sub-Saharan Africa, they're actually very different. They take on the local vernacular of their place and time and the local cultural conditions as well. So we asked ourselves, what should a British mosque be in the 21st century in Cambridge? And we also researched the sacred architecture in England and in other places. So that's the Cordova Mosque and, of course, King's College Chapel, which has these amazing English fan vaulting, which is unique to England and was an inspiration to us as well as the Galt bricks. So at the top right, you can see the Galt bricks, the Cambridge Galt bricks with the red highlights. That was something that we used as an inspiration as well. So the idea came from the Garden of Paradise, that was the inspiration. It was the idea of a calm oasis for contemplation and a grove of trees with the water fountain symbolizing the source of all life. And so there you can see the grove of trees on the site with the trees positioned together that then are formed, that come together at the top, and then we have timber surrounding it, which is the timber structure. So the whole structure is timber. And this is another example where we found the people who could make it at an early stage. So Bloomer Lehman is a fantastic Swiss company that makes timber structures, and we found them and got them involved even before we got planning. And this, I think, is one of my favourite working model drawings. You can see it's one of the most beautiful working model drawings, I think, that you can see. They had it all worked out to the last millimetre. And this is the plan. So if you see, there's Mill Road is on the left, and it's really a journey from the kind of everyday and the busy road going through a community garden, through the Islamic garden, through the portico, through the atrium. And then on either side of the atrium, you have a teaching room and a cafe, and then the ablutions on either side of the lobby into the prayer hall, which is obviously orientated towards Mecca, with the Qibla wall here on the lower level. And this is, you can see it in context. So the idea was that we wanted to do a project that fitted into its context, but also stood out. Somehow doing that together. And this is, you can see the inspiration for the brick cladding that was over the top of the CLT. And then this is the final, the use of low carbon materials and the garden, the Islamic garden. This is the atrium. These are the ablution areas. The women's is on the left and the men's is on the right. And this is the prayer hall. And this is also the prayer hall that you can see on the right. That's during COVID, with the dome, and it is probably the UK's greenest mosque. There, it's designed to be entirely naturally lit, naturally ventilated. It has no fossil fuels, and this decision was made in 2009. No fossil fuels. And the rainwater's collected and flushes the toilets, and so it's lots of green. It's also the most women-friendly mosque in the country. So we found out recently that a third of their income that they get actually comes from weddings, and they said quite openly that they think that comes from the architecture. That everyone wants to take a photograph with showing the architecture. So that's what was very nice to hear. They have about 300 weddings a year or something. Amazing. Yeah. Nice.
So this next project is there's an architect called Peter Beard Landrum, who I've collaborated with for many years. I first met him doing some teaching at Cambridge and then at the AA, and he's tended to do quite gentle projects, often in remote places. What you can see here is the high-speed one and the normal railway going through. That's Rainham Station, and so the railway severs the village of Rainham from the river, which is on the left-hand side, and this project is to connect from the top of the rather ugly footbridge that goes over the railway, this trackway that goes down to the marshes. It's an triple SI. And this is the architect's model of showing how it comes to the top of the footbridge, the existing footbridge. And what you'll notice is it's got lots of inclined timber columns. If it was to sit lightly, those columns don't meet at a point at the top. So stability comes from the combination of these columns at different angles combined with a bending stiff structure, which is the walkway. Those columns are as close to being like trees as they could be, but I mean, they are treated. They're about 600 diameter at the bottom, and the longest ones taper to 450 at the top, which you see in the completed one. But what was sort of for me, this was partly, Peter was lovely to collaborate with because he really let me say I'd like to try out these structural ideas. And I suppose this was a way of working I'd seen Peter Rice do all those years ago when he was contributing to Centre Pompidou and talking about Joe Barrett's, I knew that he had wanted to try out using cast steel as opposed to cast iron. And so I think it is quite interesting sometimes to take a structural idea and see where it leads you. And a few years before, I'd worked with Max Gogg and Meron Elam, who are Atlanta architects. And this was it didn't get built, but it was to have been really a kiosk for the Olympics. And it was actually, those columns are about 100 foot long, and it's supporting a canopy that is a timber space frame. And it has, therefore, bending stiffness. And again, the columns are at all different angles, but they don't meet together at a point. And also in the process of that, we were wondering how we would make a timber space frame. Oh, and the reason we're using timber is because Georgia Pacific owned the site and they were going to donate the timber. And we came across this engineer called Peter Bircher, German engineer, who's developed a system like the Mero steel space frame system, where you have a spherical node and then you can have elements coming in at any angle. And that's a cast steel node, and then there are steel pieces that get embedded in the timber, and then there are cross elements so it can take tension and compression. This is just showing you the bending stiff ladder, and it's supported by these timber columns. They look as if they're kind of randomly spaced. In fact, every single column goes from one point at the top on these cross members that are 3 meter centers to one of 4 positions at the ground. So they're always at the same angle to the vertical. So there's a rigor to the geometry. And just going back to this one, but what you can see is that also that we couldn't attach them to every single cross beam because we've got lots of obstructions at ground level, like a watercourse, a road, and lots of underground services. And then, of course, we had to make sure that it wouldn't wobble around too much, couldn't deflect too much. And in fact, this is the maximum deflection is height over 330, so that's fine. That's a lot better than a height over 180. But we also had to make sure that we didn't get wobbly bridge syndrome. So we had to get the natural frequency to be above 1.3 hertz. And we did lots of analysis of this. So we had to model the feet of the columns. They're attached to concrete pile caps, but they couldn't go the whole length of the pile caps because of all of these other obstructions. So it's quite short lengths of pile cap, and also the piles themselves are going through quite soft ground because we're near the river. So it was that was the major challenge. And then I'm just showing you this one. So on the top right, you can see us using Peter Bircher's method of putting a steel rod into the timber, and then with these cross dowels, so it can take tension and compression. And also in the bottom right diagram, you can see that we've actually got the equivalent of the rotule, this spherical bearing that we had at Parc de la Villette for the glass. So that this is all to make sure that we don't put bending into the timber columns, so that they could be as small as possible. So the columns are only taking tension and compression. And this is it completed, and here you can see that they are a bit tapered.
Okay, now I'm going to talk about the West Somerset Lagoon. So this is another kind of entrepreneurial project. So I was approached by some eminent engineers who are working on this project. And basically, it is a lagoon that goes from Minehead to Watchet, and the Bristol Channel actually has the second highest tidal range in the world, and it's completely untapped at the moment, which is obviously a waste. And so I was involved in doing the barrage, the Severn barrage about 15 years ago, which hasn't happened and I don't think will happen. So a lagoon is much better way of providing the tidal range energy because this is the location that we've chosen. It's outside any area of special conservation, and it provides coastal protection against sea level rise. And it's basically a semicircular shape that maximizes the lagoon area with the minimum wall perimeter. And it's outside the navigation channel to the Bristol docks and Cardiff, and also it has quite a close connection to the grid at Sherton. So very carefully located, and it's located between Minehead and Watchet. It's 14 kilometres across there, and can provide a total capacity of 2,500 megawatts of power. It's obviously good for UK energy security. It can power at least 2 million homes. We reckon that we can actually do very rapid construction, about 5 years. It's obviously a lot of money, but it is cost effective if we use regulated asset-based funding, and it's similar or cheaper than nuclear and offshore wind. And it has an exceptionally long life. So wind and solar last about 30 years, nuclear lasts about 60 years, this will last 120 years. So it's really long-term thinking, which is actually what we need at the moment. And it's also predictable and reliable, and we can use the ebb and flood tides. So we've done a master plan for it. We reckon it will provide about 8,000 jobs during construction, and that's all on the mainly on the southern Welsh coast. That all of the caissons can be constructed, but it will also provide at least 300 full-time jobs created in the area, and it's an area in need of regeneration. Minehead is really in a poor state at the moment, and this is one of the images that we've done showing what it could do to Minehead. It could really completely transform Minehead. So now getting on to the nub of what we're talking about here. I'm sure you are all aware of the climate crisis, and what really woke me up to the climate crisis was becoming aware of the IPCC report in October 2018. Maybe some of you saw that as well. But when the world's top scientists warn that we have 12 years left to avoid a climate catastrophe, I think it seems to me that we need to pay attention and do whatever we can to avoid that. And something else happened to me in 2018. I had my first grandchild, and that really does focus the mind. And now I do literally see the world through the lens of the climate emergency. It affects all the choices that I make about what I eat, how I travel, and what I do in practice. And now, just to bring it up to date, we see that obviously we've got COP at the moment, but that the tipping points are being reached, and the government has told us to prepare for 2 degrees by 2050, when my granddaughter will be 32, which is not very long. And of course, we're already exceeding planetary boundaries. We're already exceeding 12 of the planetary boundaries that have been identified by the Stockholm Resilience Centre. I think we both believe that this is the most important issue of our time, and we owe it to our children and grandchildren not to be bystanders in this. But I don't want to be a doom monger. I believe that there's hope, there are solutions, and I love this cartoon because it shows that if we respond appropriately, it can actually make the quality of our lives better, not worse. And as a construction industry, we actually have a huge responsibility. I mean, I'm sure you probably all know about this, but I'm going to say it anyway. The construction industry is the elephant in the climate room. It's responsible for 42% of carbon emissions, and a huge 62% of waste, and 50% of extracted materials. So we have a responsibility to try and turn that around. And I mean, we've been trying to do this.
There are many, and I'm sure lots of you are involved in some of these organisations. Most of these are voluntary organisations, really trying to do things. I don't think I need to go through them all, but you know, we encourage, and we encourage people who work with us, and when I speak to students, and I'm sure when Julia does as well, we're always encouraging people to speak up and just, you know, we can't be too timid about it. So, yeah.
Yeah, and collaboration and knowledge sharing is absolutely key.
Yeah. Well, Edith knows as well. I don't know if you all know about The Edge, but I think it's a fantastic voluntary group of people. It was actually first started by Jack Zuntz, who was chairman of Arup at the time, wanting RIBA and Institution of Civil Engineers to collaborate a bit more. So its primary function is to perhaps to get the professional institutions to collaborate, but it's not just the professional institutions. We're realising more and more. So in 2019, we actually organised this climate action roundtable that was chaired by Lord Deben, who at the time was the chair of the Climate Change Committee, and he had just persuaded the government to vote for the Net Zero by 2050 law. So that was really good. And after that, we got about 20 institutions and organisations to sign up to a pledge at that time. Recently, we've been doing a project about undergraduate education, because most of our undergraduate education is geared towards you just getting accreditation in your own discipline. And you emerge as a graduate without the skills to be able to, be truly climate literate, to communicate with other people. And it's not just other built environment professionals that you need to learn to talk to, but it's all the stakeholders, the lawyers, the risk assessors, the local communities. And so actually we were quite pleased that we managed to get some of the accreditation bodies like ARB and the Engineering Council and a lot of the institutions. So 19 so far have signed up to a statement which includes: it's fundamental that undergraduate education in all built and natural environment professions adequately responds to this crisis. It needs to teach climate and environmental literacy and ethics, and develop the ability in students to collaborate, communicate, challenge, and advocate. We agree that urgent action is required and that this will require active collaboration between educators, industry, professional institutions, and accreditation bodies. So now we just have to try and hold them to it. Easier said than done.
Yeah. And I'm involved in, I've helped set up Architects Declare, as I said at the beginning. I mean, presumably you guys are part of it. Yes, I'm sure Arup is. And we've got 140 signatory practices, and that's just architects, but we've actually got, in construction declares, we've got almost 7,000 practices worldwide who've signed up to the declaration. And what we're doing is we've got a kind of dual approach. On the one hand, we've produced a practice guide. We do practice masterclasses. We've got a regenerative primer, so that's about encouraging signatory practice and showing them ways to keep true to their what they've signed up to. And then on the other hand, we're trying to be leaders in the industry and change the system and change policy. I've been very much involved in that side of things. In 2024, we launched our manifesto for the next government to transform the built environment, and we had a launch in Parliament with Kate Rilworth and Caroline Lucas and what's his name? Grand Buildings. Kevin MacLeod. How could I forget? Yes, and also we, as a practice, I've basically turned the whole practice around to focus on regenerative architecture, the circular economy, and retrofit and reuse. And recently we had the circular revolution. I don't know if you heard about that, where I do have access to the whole wheel. And we took over the whole wheel, and in each capsule there were 15 people, and they had to come up with pledges and asks. So pledges from from the industry that they would do in order to create a more circular economy, because we realised that the wheel is actually quite a good symbol for the circular economy. They had to, so people in each of the capsules had to come up with asks and pledges, and there were about 450 people, 250 organisations represented, and hopefully people from I'm sure people from Arups were there. I'm sure they were part of it. And at the moment, we're trying to compile all the pledges and asks that have been done in the capsules, and produce a document that can be a kind of a starting point for the next stage. And in Marks Barfield, we're very much focused on the circular economy. And we actually did a project recently where, by reusing materials, we actually saved the client £1.65 million, which obviously the client was quite pleased with.
And actually, I'm currently a judge of this competition, which the United Nations University is having. It's international. It's open to anyone under 40, individuals or teams, and it's an ideas competition, or it could be actual projects, and it's just asking people to submit projects which embody all of these ideals. And there were 2 webinars which were pretty interesting. I actually spoke about Marks Barfield's urban mining tondo. There's a brilliant Swiss architect who spoke about an office building that they retrofitted in Zurich, which they didn't take anything off the site. So when they stripped out carpets and things, they used them as other bits of furniture or cladding or whatever. So that was a pretty fantastic project.
Yeah.
So entries to be in by early December. So here's your opportunity. And I mean, this is, this is in keeping with it, isn't it? We just can't keep tearing down buildings. We have to, and when we build buildings, we must think that it's not a design life of 60 years. I mean, what's this all about? It should be 1,000 years. And there's no reason why it shouldn't be, so long as we maintain them properly, we keep the water out. Obviously, we're going to have to replace bits, services and cladding, but the structure can be there forever if it's looked after properly.
So this is just a kind of to wrap up, really. We need to become more climate literate. We need to calculate the whole life carbon of buildings. I'm sure you're all doing that.
Yeah, they do.
Move to a circular rather than a linear mindset. Drive down regulated embodied carbon. So that's part Z. Move to plant-based biomaterials. Think about adaptive reuse in buildings. And design. We need to build less. If there's a project where the client actually doesn't. I mean, there are examples actually of people who've, architects who've said, no, you don't actually need a building. You can do something else. It's actually an Arab person who did it for an airport. Who's saying, that yes, they were, yes. Anyway, I could just tell you. I'm sure you've got examples.
But the main thing is to just to encourage everyone you meet to always speak up about it when they've got a chance. It's at the coalface. We've got to do. I mean, it's great to have all these guides and everything, but really, every time you're in a design meeting and someone is suggesting something that isn't the right solution, we've all got to get bolder and just speak up. And be innovative, come up with the solutions.
And be good ancestors.
I think that's it.
That's it.
Apologies for going on a bit.
Any questions?
Tremendously inspiring, really wonderful. And I just remembered William Morris saying that you shouldn't have anything in your home which isn't either beautiful or practical, and all your work was both beautiful and practical, and it can't be practical if it is not environmentally sensitive as well. Questions from the floor?
Or the sky.
Thank you for the talk, very good as usual. Then I didn't know this whole story.
The microphone a bit higher.
Yes, sorry, thank you. I didn't know the whole story behind the London Eye, especially at the beginning, and I actually thought it was like, it's the government that built it. But I think, how do you see now a project like that one going, whether it will be accepted by the public if you were to propose the same right now, and what was the differentiating factor back then that got the people behind?
Fact that the millennium was, I think that was the kind of key factor, really, that there was a number of projects that were being done, because it was this, once every 1,000 years. So whether it would be accepted now, I don't know.
I mean, every so often something comes along which does seem to be a catalyst, doesn't it? Like the 2012 Olympics sparked a whole lot of projects.
Yeah.
But I suppose the thing to do is to be alert for the next opportunity to do something special. It won't be the wheel, of course. It'll be something completely different.
Yes, it'll be something different. Yeah.
But just to kind of have your eyes and ears open to what can be special, because I think it's good for us to have projects that represent our age a bit, and I think that'd be nice if that happens always.
Yeah.
Yeah, thank you very much. That was fascinating. I was just wondering, out of curiosity, do you remember where were you during the millennium?
Yes, we were both there.
We were there, yes.
Yeah, how was the party?
We were there. That picture of the fireworks, we were there. Actually, so myself and David, we were actually on the other side. We were on the other side of the river where Tony Blair was. We actually.
Oh yeah. Yes.
We were actually.
But I was underneath the wheel.
Yes. We had to go and shake hands with Tony Blair and Cherry Blair, and then we had to come back over, around through the crowds and back into the.
So that's where you went.
That's where we were. Yeah. And David gave Cherry Blair a kiss on the cheek, which was probably not a bit.
Oops.
Oops.
Just one question for me. How do you try and bring about this kind of relationship between the architect and the engineer? How do you bring that through to the next generation?
So I would encourage young architects and engineers to do those sorts of competitions that come along. I mean, I can't remember what it was called, but there always used to be one which was for teams. Does it still happen? Sorry?
There's a hook part competition.
Oh, yeah.
Yeah.
Which is, that's a very nice design-led, architects and engineers designing a folly or a structure, which is very nice. But
that's what Francis Archer is very involved.
Yes, yeah.
And there used to be another one that also had to have a QS in it. So it had to have architect, structural engineer, services engineer, and QS to be a team. And they had to do. I can't remember what that project was called. It used to happen every year. And
next year there might be others.
Yeah, so it's good to keep looking out for that. I think that's, but also this undergraduate education thing. That's where, there are a few places. I mean, Leeds has been doing it forever, where they have architects and engineers working together, and since Appold's time, at Bath, and now UCL and lots of places.
UCL. So I'm an external examiner at UCL, and there's a course that is for architecture. And engineering, both engineering.
And Southampton's been doing it since I was the visiting professor there. I got them to set it up. So there are, but there's very few and far between, and so we need to encourage that to happen more. But I mean, at Arup, you're lucky you've got all the disciplines, so you could just do it in your lunch hours.
I mean, is there much cross fertilization? There must be. I mean, how does it happen here?
Yeah, it definitely happens. It's very it's project based, I'd say.
Right.
Project based, but then that fosters relationships, and I think one of the benefits of being here is that you get to have a hotline. You start to gain interests, and actually you can have informal conversations that lead to more exciting kind of developments that are not project based. So it's about relationship building, as in your case, I can imagine, because you get interested and you inspire each other, and that's when good things happen.
I remember when Julia once asked me if they were going in for the Grand Buildings competition, which was for one of the buildings in Trafalgar Square, when Julia was still at Foster's and David at Rogers, and we would meet in their house on a Saturday morning. And for me, it was brilliant, because I was in my mid-20s, I think, and I think it was the first time that I had gone to a design meeting with architects on my own without, you know, an elderly gentleman looking over my shoulder. and I did start the conversation, and there is no substitute for working with the, you know, architects and engineers working together over a whole series of projects, because the crucial thing for collaboration is trust and respect, and that just takes time, doesn't it?
Yeah, for sure.
Yeah.
Can I ask another quick question?
Yeah.
The whole essence of this talk was just super inspiring, you know, visionary, and I just wondered you know, it's crossed decades of, you know, different social pressures as well. So coming from, you know, the millennium when you wanted to be celebratory and always with the theme of efficiency, but now coming to a place where we've got to be so sensitive about materials. I just wonder if you ever reflect back on any of these incredible projects and think, how could that have been done today with the material consciousness that we have? And also, so many of your projects are wonderfully celebratory and they're innovative and big scale, but sometimes I think when we talk about material efficiency, we can't see beyond small scale interventions. I just wonder if you ponder that.
That's why I love the Rainham to the River project, because I think it's kind of rather modest, and I think you can do that with anything, with a house extension even. You can just always just keep trying. Certainly we're thinking about things differently. I wasn't thinking about embodied carbon when I was working on Stansted Airport all those years ago. I mean, I don't. There's lots of things we wouldn't do today, aren't there, that we've done in the past.
Yes,
But-
I'm not sure how you'd redesign the wheel though. I mean, well, we did it twice. We actually did look at the embodied carbon of the wheel, and it's not actually that huge. And certainly in energy terms, it's actually very efficient. Once it starts turning, it's actually really efficient. It's not. It doesn't use up.
Yeah, I mean,
it doesn't use up a lot of energy.
yeah.
So it's difficult to tell. I mean, in terms of the queue, would we do that differently? Again, I think the choice was right. I think Corten was right.
And especially as we didn't have to keep painting it. I mean, that's brilliant.
And that it'll last. It'll last.
Yeah. It has to be inspected.
It has to be inspected. Yes, absolutely.
Well, the wheel has a thoroughgoing MOT every January.
It does. Yes, it does. Yes.
Yeah, I guess it's that's the essence of innovation, isn't it? That you do it in an efficient way and it's done responsibly. So they've got very what's the word? Robust sustainability credentials kind of baked in.
I like the idea of sufficiency.
Sufficiency. Yeah.
Sufficiency. So I like the idea of sufficiency, because I think it has to be efficient, and you know, and we all know that nature designs very efficiently and very beautifully. But it's like, you know, if it's just efficient and it doesn't have the beautiful side, it doesn't have the beauty, then I think it's failing. So I think, in my mind, sufficiency has the efficiency and the beauty combined.
That's a nice way to think about it.
Anyone else? Well, another thought from my side is the kind of partnership with manufacturers, the actual making, and how that has been central to your work, and how that partnership has come on very early. It seems to be a really interesting theme. How did that all begin? How did you come to know that was the right route?
Well, it's just, if you are trying to do something unusual, something that hasn't been done before, you really have to find the people that are going to make it. I mean, the number of phone calls we had to make before we found Poma. I mean, for the capsules on the London Eye, you know, we looked for, you know, car manufacturers, boat manufacturers, bus manufacturers. We looked at so many different people, and if we didn't know who was going to build it and how it was going to get built, then, you know, there's no point in even, you know, going. You can't go from stage 1 to stage 2, really. So that was very clear right from the beginning, that you do need to talk to people who are going to, and with the mosque as well, because you need to know that it's affordable.
And actually, I'd like to mention, I didn't mention that I'd worked for, well, you did, that I worked for Bird Air, who make permanent fabric roofs, and So they are a manufacturer, and they also do all the form finding and patterning, and that was quite early on in my career. I was just 4 years after I graduated, and I think that was it was the same thing, because it's very easy to draw a fabric roof which is pre-stressed and not know how you can get the tension into the fabric without ripping it to pieces, and unless you have a method, you know, like the cone, where you lift up the bit in the middle so that the cables kind of press against the hoops. If you just don't know how that's going to work, you can't actually do the design to start with. So I think that was
and in terms of construction as well.
That was.
Yeah.
I was working for we put them up.
Yeah, you did. Yeah.
Terrific. Well, you can see Francis and Lisa there, and Ed, maybe we'll just finish off with Ed's words here. Ed Tricklebank, thank you so much. Amazing talk, wonderful exemplification of design, collaboration, and long-term collaborative relationships.
Oh, thank
you.
Yeah. Okay.
Thank you very much.
Okay.